In this video, we will be discussing the basics of thermodynamics and its laws. So what is thermodynamics? Well, thermodynamics in its most basic form is the study of energy and heat and how it is transferred and transformed in chemical reactions. And in even simpler terms, it's the study of energy and heat. In a chemical reaction, you will have a system and its surroundings. In this particular example, you have a flask, and within the flask, we have chemicals. The system is what we are studying, and the surroundings are just everything else that can exchange energy with it. So, the system would be the chemicals within the flask. The surroundings would be the flask and the air and everything around it. There are multiple laws for thermodynamics. The first law of thermodynamics is the law of conservation of energy. This means energy cannot be created or destroyed, only transferred or changed from one form to another. Energy is conserved in the universe, leaving the total energy in the universe constant. So energy lost by the system equals the amount of energy gained by the surroundings, and vice versa. To apply this first law of thermodynamics, we're going to look at this chemical reaction. This chemical reaction is releasing heat into the surroundings. So the system is emitting heat, losing heat, which means the surroundings are gaining it. This also works in the reverse. If our system is taking in heat, gaining energy, it is taking it away from the system. Now this is all congruent with the first law of thermodynamics, with energy cannot be created or destroyed, because when the system loses energy to the surroundings gain it. If the system gains energy, the surroundings lose it, leaving the universe in a constant state of equilibrium. Another way to look at this first law of thermodynamics is in this equation. Delta E equals Q plus W. Delta E is the change in energy of the system. Q is the heat, or energy transferred as heat. W is the work, or the energy used to do something. If energy goes into a system, the overall energy increases. If energy leaves the system, the overall energy decreases. But the total energy is always conserved. The second law of thermodynamics states that the disorder or entropy of the universe tends to increase. So basically, spontaneous reactions tend to increase the disorder of the universe. But what is entropy? Well, entropy is just a measure of disorder, randomness, or energy dispersal within a thermodynamic system. Now let's apply the second law of thermodynamics to this picture. On the right side, we have a clean and ordered room, meaning it has very low entropy. According to the second law of thermodynamics, the universe will spontaneously leave you with this messy, disordered, high entropy room on the left. Now, if we wanted to go back to the clean room on the right, energy is required, meaning it's no longer a spontaneous reaction. The way we discuss thermodynamics can be shown in this mathematical equation called Gibbs free energy equation, which reads delta G equals delta H minus T times delta S. Delta G is Gibbs free energy. Delta H is enthalpy, or heat released or absorbed. T is temperature, which has to be in Kelvin. Delta S is entropy, or disorder. Now, if delta G is less than 0, the reaction is spontaneous and will happen on its own. If delta G is greater than 0, this means it's not spontaneous. Energy is required for the reaction to go further. If delta G is 0, the system is at equilibrium. Reactions favor lower energy and higher disorder. Now let's apply what we just learned. Now, I want you to pause the video and use Gibbs' free energy equation to solve this problem. Now, after you plug the variables into the equation, you get delta G equals negative 20.2 kilojoules per mole. Now, is this reaction spontaneous, non-spontaneous, or is it at equilibrium? So, we know when delta G is less than 0, the reaction is spontaneous. When delta G is more than 0, it's not spontaneous. And when delta G equals 0, the reaction is equilibrium. So, in this particular reaction, delta G equals negative 20.2, which is less than 0. So, we know that the reaction is spontaneous. Now that's all I have for the basics of thermodynamics and the first 2 laws. I hope you learned something, and thank you for watching.